Okay, today we're talking about P.4 or P.4, the fourth section in the preparatory chapter. We're going to start talking about what we term polynomials. A polynomial, we look at that word poly, we know that that means many, and then nomial or nomial means a term in math. And so when we talk about a polynomial, it's an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable. So we're talking about lots of x's, x squared, x cubed, things like that. Those typically show up in polynomials. And let's just really make this really clear. A monomial means there's one term. See, there's one single thing here. 2 and x, yes, but they're multiplied together, so they're one thing. When we talk about a binomial, the term bi means we've got to have two. So mono is 1, bi is 2. So we see the 2x, the 3y, there's two terms there. If we come down to trinomial, we start to see different x's with different exponents. We can see there are three pieces, 1, 2, 3. And then a polynomial, when we throw polynomial at a term, polynomial could mean a binomial or a trinomial or something bigger. Typically we say polynomial, we're thinking bigger because there are these other names, binomial and trinomial, that covers that base. But the idea is you're going to see multiple x's and different exponents added or subtracted together. That's sort of the goal there. So what's not a polynomial? Things that are not okay. X inside of a square root or a cube root, that's no good. X's that have negative exponents or show up in the denominator. These are really related cases because we know negative exponents push things to the denominator. So either way, x is in the bottom or x has a negative exponent makes it a non-polynomial. X is not allowed to be the exponent, and the exponents cannot be fractional. Okay, no fractional exponents here. So those are things to be worried about or to look out for. They make things non-polynomial. So we're really looking for those really standard squared and cubed x equations that you're used to seeing growing up through math. So when we talk about the degree of a polynomial, we're talking about the highest. We're going to switch this word degree out for exponent. Okay, we're looking for the biggest exponent on an x. Okay, so if we look at this, this is 3x to the first, so that's a degree of 1. 7x cubed, degree of 3. Now, these are all variables, and so you got to realize that you got 1, 3, and 4. You combine those together, you get 8. But this is very rare that we see something like this. Okay, but let's come down and let's look at this example problem. If we look at the degree of the following polynomial, we got the degree of each of these. We're going to look at each one of these, just the variables. Don't worry about the numbers in front of the variables. So this is 5 plus 3 is 8 plus 1 would be 9. That's a degree 9. This is 1 and then 3. That's a degree 4. This is 2, 1, and 2. That's degree 5. So the degree would be 9 in this problem. Again, once we really get into the problems, you're not going to see a lot of combined variables like this. They're not as common as you might think. But the degree is the highest exponent when you combine all the variables. Okay? Not the whole numbers, just the variables. Well, let's look at some subtraction, some addition of these polynomials. Things you have to keep track of is that variables have to match in order to combine them. And so when I see 7m squared, I'm looking for another m squared term. It must match perfectly. So there I get 11m squared plus, there's this leftover 3m that couldn't combine with the others. It's important. We cannot combine these even though they both have an m. They have to be identical. And m squared is not m. We come down to question number 2. It's r squared plus s squared minus this stuff here. Well, the way we always treat this is we're trying to subtract the whole thing. So it's easier if we distribute the negative. Okay? So we now have r squared plus s squared minus 5r squared minus 4s squared. So we distribute that negative, it turns both of them negative. Now if I look at my r squareds, I've got 1r squared and a minus 5r squared. That's the same as negative 4r squared And if I look at my s's, I've got 1s squared minus 4s squared would be negative 3s squared. And there would be our answer. So you need to make sure that when you subtract a polynomial, you distribute the negative to make sure that you treat everything equally. Now this is a plus again. Pluses, there's no change if you were to distribute a plus 1. So I don't need to worry about it. I just get to look through here for like terms. I have 10pq, 2pq, and 6pq, and they are all positive. So I'm just going to add them up to get 18pq. Then I have this 3p and a negative 5p for a negative 2p. Okay. And this last one, again, we see this negative 1 distributed. If you don't distribute this, you lend yourself to a lot of headaches. It takes an extra step, but it's really important to make sure we're accurate. So 14d cubed minus 8 minus 6d cubed minus 1 times minus 2 is plus 2d, and then minus 1. If I'm looking for like terms, there's 14 and negative 6d cubed. That makes a total of 8d cubed. Then I look for the next time I see a variable, there's 2d. There's nothing to combine, so plus 2d. And then a negative 8 and a negative 1 makes negative 9. Okay. In multiplying different types of equations, there's some rules to keep in mind. A monomial times a monomial. What's 1 times 1? Be 1. A monomial times a binomial would be 2. A binomial times a binomial would be 4. And a monomial times a trinomial would be 3. So this tells me how many terms there are before I simplify. Down here, when I get 2 terms, it might turn out that they actually combine in some way. Right here, this binomial, even though there's 4, oftentimes our answer only has 3 terms. It just depends. So let's look at some quick examples and see if we can perform this multiplication, or see how the multiplication is performed. 3x squared times x plus 5. So this is a monomial, that's a 1 term, times 2 terms. I would expect 2 terms. And if you look down here, that's exactly what we get. The 3x squared needs to distribute times both of these. We're going to use the law of distribution. 3x squared times x is 3x to the 3rd. And then 3x squared times 5 is 15x squared. And there's our answer for that. Let's look at a couple others. If we have a binomial times a binomial, we can use the FOIL algorithm, where we do the first in each parentheses, then we do the outer in each parentheses, we do the inner on each parentheses, and then we would do the last for each parentheses. 5x times 4x is 20x squared, and so on. And this is what I mean. We got 4 terms, but oftentimes the 2 in the middle combine. A 5 and a negative 12 gives us negative 7. Down here, we have a binomial times a trinomial, which means we should get 2 times 3, we should get 6 terms. So 3g times each of these gives us the first in blue, and then negative 3 times each of these gives us the next 3 in red. And even though I started with 6 terms here, by combining my like terms, I ended up with just 4 terms. Okay, so be careful with that. Another option for doing these is to build an array. Okay, for instance, if I did 3g and minus 3 here, and I did 2g squared plus 4g minus 4, don't mind my sloppy writing, 3g times 2g squared would be 6g cubed, and we can see that first term right there. This gives you that sort of box idea that, hey, area box is length times width. We just multiply length times width. and that can work out really nicely. Now we just want to try a couple more. We look here, we have one term, we have one term. So this is just straight multiplication. 3x times negative 7x cubed y. Let's do the 3 and the negative 7. That's negative 21. X times x cubed, that's x to the 4th. And there's a y that's just left over. Down here when we do the FOIL, y times 2y is 2y squared. Y times negative 5 is negative 5y. Now I've used this y both times, so it's done. 4 times 2y is a positive 8y, and 4 times negative 5 is a negative 20. I've used the 4 both times. Now I do want to combine the like terms, so I get 2y squared plus 3y minus 20. And we're done. This last one, number 3, last one in the set, is a monomial times a trinomial. So I'm expecting 3 parts. And I'm just going to distribute 3 times. Negative 12w times 2, w to the 4th is negative 24, that's the number, w to the 5th, because remember this is w to the 1, and we're adding exponents. Now a negative times a negative is a positive. 8 times 12 is 96, w to the 3rd. And then negative 12 times 3 is a negative 36, w to the 1st. And there's my 3 terms. There are no like terms. So I'm done. Good luck, and we'll see you in class.